This is a part 2 of our this week's review video. On part 1, I talked about lithography. Now I'll be talking about etching process. Now, etching process, we use various corrosive chemicals to dig through our wafers, and there exists some figure merits on the process. The first one being etch rate, rate being how fast can the chemicals dig through the wafers. Next is uniformity. The uniformity is when we dig through the chemicals, dig through the wafers, will it move out the contents evenly on the entire surface of the wafer. Next is the etch profile. There are two profiles in etching process. The first one being isotropic, where the etching material just digs through the whole direction on our wafer. And second, the next one being an anisotropic etch profile, which only digs downwards, which only the chemicals dig downwards on the wafer. The final figure merit is etch selectivity. The selectivity meaning when we etch some materials, will it dissolve only wafers or only our desired materials, or it will just eat through everything. There exists two kinds of etching process, one being wet and the another being dry etch technique. The wet etch is a fairly easy process because we dump the wafers on our liquid chemicals. So it is very easy to achieve. However, the etch profile is very isotropic, so it is not very good on our desired devices. So we tend to use dry etch more because it has an anisotropic profile. However, we use gas and plasma, which is more expensive and hard to function than the wet etch technique. However, so you can see some pros and cons on wet and dry etching techniques. However, there's one method of etching that combines those two for maximum benefits, that being a deep reactive ion etching. Deep reactive ion etching, we use both methods, wet and dry, as I previously said. How it gets done is we use plasma to carry the chemicals to the wafer, and once the wafer touches the material, once the chemicals touches the wafer, it will dig through the wafer just like wet etching. So in the end, we end up with both two good results, being highly anisotropic etching process with high aspect ratio. However, there's some downsides to it because we use a chemical wet etch in the end on the wafer. It will have a isotropic profile, which will be called scallops on our sidewalls. So we need one separate process to remove those scallops. And this is it, and thank you for listening for part 1 and part 2 of our review videos.